All right, hypothesis testing. Awesome. You have to be, there is actually a very good setup. And once you understand the setup, you can kind of move things or rephrase things to kind of work things in your favor. But you got to kind of understand what they're talking about first. So what we're going to do is we're going to test some claim. And the key word here is actually a claim. Like, for example, on your food, they claim sometimes that if you get candy, they'll claim each one it weighs at least this much, right? Or they'll claim that each serving gives you this many grams of fat, or things like that. They make claims, correct? Okay? And so what we're going to do is we're going to test those claims that have been made. Okay? And there's lots of claims out there of things that could have happened by using a sample. Because obviously we're not going to go get every piece of candy and measure it. We're just going to take a sample and figure out, well, how confident are we that their claim is wrong, basically, is what we're going to look for. So we're going to see, do we actually believe it, and we're going to try and prove it wrong is really what's going to happen. If a claim about a population parameter basically is called a statistical hypothesis, because it's a population parameter, so I take a, why is it called a statistical hypothesis? It's from a sample, exactly. That's why it's called statistical, because there is some stat there that I'm going to make a hypothesis about the parameter. And there are two types of hypothesis, or hypotheses. One of them is called the null hypothesis. Okay? The one thing you need to know about the null hypothesis is basically all you can do, the only thing we can do is reject it. That's all you can do with a null hypothesis. You cannot support it. You can only reject it. A little bit. An alternate hypothesis, you can't reject, but you can support. Okay? So keep that in mind. What you're going to do with the null and alternate hypothesis is when you put the two of them together, it'll be all possibilities.
So like if you're asking a question, is that what it's referring to?
Well, there's going to be a claim out there, and based on that claim, we are going to come up with a null hypothesis and an alternate hypothesis that'll come up with all possibilities. And what we're going to do is be very careful of how we word these hypotheses so that we can kind of get to what we want. And that should make some sense as we go through today. In fact, I think I'm going to make you come up with proper, at the very end here, I'm going to have you come up with how would you word it if you wanted this to happen? How would you word it if you wanted that to happen? Okay, and once, if you get those two at the end, you've got this hypothesis thing kind of figured out. Okay? So the thing you need to know about the null hypothesis is normally will be H sub 0 or H, so that's about the only one I've ever seen. So hypothesis sub O or sub 0. It is some hypothesis that contains a statement that will have an equality in it. So it'll either be equal to, less than or equal to, or greater than or equal to. But the equality is always in the null, which means if the null always has the equality, the alternate, which gets everything else, better not have an equality, right? So it's got to be some kind of inequality. And notice that the last one there could be not equal at all, right? And here is greater than, there's less than. And it's very important to realize that it has to be the opposite of the null hypothesis. So let's, for an example for you so that you can see one, what if I said up here that the mean is greater than or equal to 5 for some sample? For the null, can you make the alternate based on that information? Yes, it would be that mu is less than. You can't have equal to in the alternate. Can't. It's forbidden. Mu is less than 5. Do you agree if I put those two together, I have all possibilities for that mean? Don't I have every single possibility out there? Right? Or what if we said that the, what's that stand for? Variance was equal to 7. How would I make the, get everything? It's got to be the complement. How would I get every other possibility, but still be, the variance is not equal to 7. Is that every single possibility out there? It is. And obviously there's only one more. Let's say we said the, well, probability or proportion or whatever you want. Okay, we'll say is, well, what would this one be then? The one we haven't done would be less than or equal to 0.43 or something like that. So the proportion is 43%, right? Or less than or equal to 43%. So down here we would say the opposite of that one is And does that take care of all possibilities in each case? It does, and that's all you're looking at. So what they basically have said, put the equal to on this one and don't put it on that one. Okay? And so that's how sometimes you have to, when you're phrasing things, you might want to say, you might not want to say less than or equal to something. You might want to just say less than, because it might help you out. So the three things you got to keep straight, there's a null hypothesis and an alternate hypothesis. One of those two will actually be your claim. The claim that's made. Somebody's making a claim, and it's going to be one of these two. Do we know which one for sure? Nope. But what can you do to a null hypothesis? The only thing you can do is reject it. What can you do with alternate? The only thing you can do is support it. Because the only thing you can do is reject that one. So then you can support this one. Okay? And you'll see how that works as we go along. So let's just try a couple. Write the claim as a mathematical sentence for each of these possibilities here. State the null and alternate hypothesis. I would say do that first. State the null and alternate, and then see which one of them is actually the claim. All right, so let's go ahead. Let's state the null for this one. I'll help you out with the first one, and then you go from there. So there's a university out there that claims that the proportion of its students who graduate in 4 years is 82%. Okay, so we're going to do P, right? That's a mathematical sentence. That's what proportion is, right? P. Now remember, the null hypothesis has to have some equality in it, right? So this is flat out saying that the proportion is what? 82. So am I going to do greater than, less than, any of those? No, I'm just going to flat out say equals 0.82, right? That is what they are saying. Do you agree with that? So the alternate, which is little a down there, right, is, you got to have all possibilities here, that equal to. So I always start by doing those two. Now let's read it again and figure out, of those two, which is actually the claim. So the university claims that the proportion is that. The first one. Is it always going to be that one? No. So basically all I can do in this problem, now what can I do with the null? I can only, so the only thing I can do with this setup is reject the claim. I can't support it because the claim is in the one I can only reject. What if the claim was over here? What if this was the actual claim? I can only support the claim. I can't reject it. It depends on where it is. So why don't you try B and C right now on your own. Oh, yes, question. Exactly, that's the key. It depends on how you want to word things as to which one actually ends up being the claim. Okay, and that's the tricky part that you're going to have to think about when you do these tests. Okay, how do I word this so that it works out right? So try B and C, write the null and alternate, and then just state which one is actually the claim. Okay, so let's take a look, see how you did, and then I'm going to ask you maybe an interesting question here to see if you can alter where the claim would go. How could you reword it to alter it? All right. So this one here, the null. I always start with the null. I don't know why I do that. I guess just so I know that's the one that has to have equal in it, right? So here it says that there is a mean flow. So mean, right, is less than 2.5 gallons per minute. That's a tough one. So if I just say less than, where should that go? If I just say less than 2.5, that should go over here, right? Isn't that where that goes? So then this one must be, right? So I guess I do kind of jump around which one I do. I guess I do whichever one it says first. I put it where it belongs, and then I do the opposite for the other one, right? That's how it is. So remember, the null always has to have the equal to. That's how you tell them apart. Okay. So which one of the two is the claim? Yeah, alternate is. That's the claim. So in this problem, will I be allowed to reject the claim? The only thing I do here is support the claim. Can I say with 100% certainty the claim? No, but I can support it. Because you can support the alternate, and you can only reject the null. Okay. So how could I change this wording so that the claim was actually the null? What if I wanted to reject this claim? It would have to be in the null then, right? So how could I do that? Yes? Yeah, you could say is less than or equal to 2.5. Yeah. Or you could even say, you know, the claim is that it's greater than or equal to 2.5. Just put the equal to part in there, right? Or yeah, say at least. Yeah, there's lots of ways you could change it, but just make sure that whatever you say in your claim has an equality in it. And then I could reject the claim. But here, all I can do is support the claim because it's in the alternate. Okay. So how about a serial company claims? Which color should we use? Green. That the mean height, again, it says is more than 20 ounces. So if the mean is actually more, where should I actually put that information that the mean is more? Alternate, right? So the mean is more than 20. So over here, the mean would have to be less than or equal to 20. And so once again, which one is the claim? The alternate. And I think you saw in the last one how we could change things to actually move the claim, right? So I can only support this one. I can't reject it. I can't say, nope, it's wrong. I'm going to say, yep, looks pretty good. That's about all I can say. But I can't say with 100% certainty. That's always the problem with stats.
Why can't you support?
Because of the setup of the testing. What we're going to do is we're going to find out how probable is it. In every case, here's what's going to happen. No matter where the claim is, we're always going to try and reject the null. We're going to say, how probable is the null? And we're going to say, well, if the probability is below this, it's no good. Okay, we're always going to try and reject the null. This is the setup that's been made, and it works very, very well. Yeah, it's a weird one, I know. But no matter what we do, we're not going to try and actually support this. It's just a byproduct. We're always going to try and reject this one. We're going to try. We might not be able to, though. But we're going to give it a shot. Okay? But, of course, there could be errors. So it says here, we will always test the null hypothesis no matter where the claim is. Always test the null. But let's face it, there could be errors. The two errors are either I reject it and I wasn't supposed to, or I don't reject it and I was supposed to, right? And that's two claims. So type 1 error, and I have an interesting little sketch we're going to do on this one. Type 1 error occurs if that null hypothesis is rejected. So I rejected it, but I wasn't supposed to. Whoops. You can try. You try to reject it. It's the only one that can be rejected, Paul. How about that? The null hypothesis can be rejected, but doesn't have to be. But I can't support it exactly. The null hypothesis can be rejected. And so we're going to try. And so sometimes what's going to happen is we're going to reject it, but oops, we weren't supposed to. My bad. So type 2 error occurs if it is not rejected when I was supposed to. So you say, oh, that null hypothesis looks good, but yeah, oops, it wasn't. Okay. So I'm going to move these two up, actually, and I'll give you a nice little, I don't know if you have room on your paper, but here's one way I look at it. In our judicial system, we actually have a null hypothesis. Innocent until proven guilty. So you have to reject that, right? You have to reject that, you're not innocent, you're guilty, right? You have to reject that, and you have to have a burden of proof, right? And so look at it this way. Here I will put, and you don't have to write this down if you don't have room. Here's your not guilty verdict. Do you agree that's kind of what we're going in with? Is a not guilty verdict, right? That's your null hypothesis. There you go. Our job is to reject that, right? So that's our claim. We're trying to reject it. Well, if a not guilty verdict is one option, what's another option is that you're guilty, right? So guilty verdict. Now, those are the hypotheses. Do we actually know the truth necessarily at this point? No. So either up here, the defendant, let's say the defendant is actually innocent. Okay? And over here, the defendant is actually guilty. Do you agree there are times mistakes are made? Are there times that somebody is actually guilty and is deemed innocent? And are there times somebody's innocent and goes to jail? Yeah, both happen, correct? Now let's find out, where do those errors happen? Our null hypothesis is that you are not guilty, right? You have to prove it. So let's say that you are not guilty and you are found innocent. Is that what's supposed to happen? Yeah, so we would either call that was correct, or we could call that justice, or whatever you want to write in there, but let's call it, we'll call it justice, okay? So in other words, our hypothesis test worked the way it was supposed to, correct? Where else does it work the way it's supposed to? Bottom right, guilty verdict, and you were actually guilty, right? That's justice. That's what's supposed to happen. The other, well, or unlucky, depending on where you're. So if you're not guilty, but you're found guilty, ooh, that's not good, right? Or if you are guilty and found innocent, well, you're probably happy about that, I guess, but it's still an error. Do you agree with that? So in this first one down here, the guilty verdict meant that the null hypothesis was rejected, correct? This right here says the null hypothesis that you were innocent was rejected. Was it supposed to be rejected? In this case right here. No, so what type error was that? It's type 1, exactly. It was rejected. The null hypothesis of being innocent until proven guilty, or the hypothesis that you are innocent, was rejected, but whoops, wasn't supposed to be. Well, not really. I mean, that's a good one, right? I mean, that's the guilty verdict came through it. Well, yeah, you were innocent and you came through. You're like, whoops, oh, that stinks. Now the other one is, so here's your null hypothesis, not guilty, right? Verdict. So you didn't reject it, but you were supposed to. So this is type 2. So you got not a guilty verdict, but you were actually guilty. And let's face it, that happens, right? Otherwise, defense lawyers wouldn't get paid so much. Okay. So really, if you look at this, you got a 2 out of 4 chance of getting it right. That's our judicial system. Yes. Okay. Does that help, or did that make it worse? I don't know. Yeah, well, other than that, does it help kind of understand that there are 2 types of errors? And then there's obviously ways that it could work, right? You reject it and you were supposed to, or you don't reject it and weren't supposed to. So there's 2 ways of it. But there are definitely errors in there as well. And I think we agree that that happens. Yeah, I mean, it's unfortunate, but it does happen. All right, so let's try this. So the USDA limit for salmonella contamination for chicken is 20%, which is a little scary, but because that's actually a number from some. I found that number somewhere, so that scares me a little bit. So they're saying if you get above 20%, shut down, right? That's what they're saying. Below 20%, you're okay. So a meat packing company claims that its chicken falls within the limit. So their claim is that we are good. You perform a hypothesis test to determine whether the company's claim is true. So the first thing, let's actually just write out the 2 hypotheses. And then find out where is the claim in all of this nonsense. So, well, we're talking about P, right? Probability. So which one's the null? That's the limit, though. So yeah, the limit is 20 up, so 20 up. So and also its P is less than or equal to 0.20, right? So here is P is, and really, as far as this problem was concerned, if you wanted to say, 0.19 or something, whatever, I would have. That's not the idea of this one, so I would have taken that. But, so of those 2, which one actually is the claim? Yeah, this one, right? Is actually the claim. So do you see how I've almost started every problem that way? Get our 2 hypotheses written down, make sure they cover everything. and then figure out which one's actually the claim. Because let's face it, I could have rewritten this one to make the other one the claim, right? And so I perform my test. So I'm not really asking you to do the test yet. And we're not going to do that. We have to figure this stuff out before we actually do a test, right? Because let's face it, this is tricky enough, right? When will a type 1 or type 2 error occur? So kind of explain it is what we're going to do. So type 1 error. Well, remember, type 1 is when you reject it, but, whoops, I wasn't supposed to do that. So what that means is I went in there and said, you know what, company, sorry, but your proportion is not below 20%. Do you understand that? But they actually were. Is that bad? Well, we'll talk about that. So that means I went in and said, did my test and said, I rejected. I said you are not okay. But oops, you were. Yeah, sorry about that. I just shut down your company, but yeah, don't sue me or anything. All right? Yeah, it's a couple million. It's okay. So you see that's a type 1. You understand that then? So then how would I do a type 2? Yeah, I went in and I said, you are good. But, oops, you were not. I think the next question, I kind of left it on there. It's an interesting question. So of these two errors, which one is more serious? In your opinion? You could have your own opinion. I mean, why? Yeah.
Because, like, even if, like, in type 1, they got shut down, but they were okay. In type 2, they were going, and all these people were getting sick.
Okay.
So, I mean, I'd rather have something shut down.
Okay. So what was said there is in type 1, yeah, you got shut down, but in type 2, people are going to get sick. So good, you understand what's happening there. So type 2, I've heard from a lot of people, is worse. What would happen in a type 1 error, though, that could be bad?
Losing their jobs.
People losing their jobs, and then people, let's face it, people kind of freaking out. What, your chicken's bad? Then they're not going to eat chicken. You know what I mean? And then they're freaking out. So really, both are bad. And this is an opinion, right? Obviously, the businessman's going to have a different opinion than the person eating the chicken. Okay, so that's why it says in your opinion. If you're eating this chicken, obviously you're going to think type 2 is worse. If you're running that company, you're going to say, what are you talking about? You shut me down and I was good. I just lost millions of dollars and all these people lost their job. Okay, so they're both bad, right? We can agree with that. In this case, they're both bad. Okay, but for different reasons. Okay, so are you starting to get there with this? It's a little weird. Okay, that's the number that actually scared me, but 20%. Anyway, yeah, maybe, right? So this might make some more sense for you once we do this. In a hypothesis test, you are going to come up with some level of significance. You're going to come up with where should this answer be? Should it be really good, really low? It's the minimum allowable probability of making a type 1 error. So I want to minimize making a type 1 error. So apparently, like in that last one, type 2, whatever. And it's denoted by, what's that letter? Alpha. The probability of type 2 error is denoted by beta. Common values for alpha are 0.10, 0.05, 0.0. So I want to make sure I only make a type 1 error 10% of the time, or 5% of the time, or 1% of the time. Obviously, these numbers shouldn't be a big surprise because that's the opposite of 90, 95, and 99. So those are your, we've heard those, right? I mean, those are key. And so the key here, though, is that you're trying to minimize making a type 1 error, which is rejecting it. But yeah, you weren't supposed to. Whoops. Okay. And so what we're going to find is a rejection region, because we know how to find probabilities, right? We got that table. Go in there and find it. For which the null hypothesis is not probable. Okay. And if that test statistic falls in that region, we're going to say, you know what? Null hypothesis, you are rejected. Okay. Now, does that say anything about the claim? Well, it depends on where the claim was. If the claim was in the null hypothesis, you just rejected your claim. If the claim was in the alternate, you just supported it. There you go. Now you get it. Okay. So let's say here's the key here. And this is a trick, really. Here's how I remember them. If in your null and your alternate hypothesis, you have that symbol, is how I remember it. You have a left-tailed test. So over here. So you would say that this area is, well, which one do you want to use? I don't care which of these numbers we use. Type 1 error, what do we want our percent to be? Well, 0.10, right? Is that something we could go find in that normal distribution table? Could we go find 0.10 on a one-tailed test? Sure. Okay. So it's a left-tailed test. Big surprise. What if you got that one? I just say it points to where your tail is. Left, right. That's my cheat. That's how I do it. Do you want to stick with that one, or do we want to put a different number in there? Stick with it? Okay. Now realize these could be different numbers, though, right? This could be either 5% or 1% out there, right? Out here, we're just choosing 0.10 because that's what you want to do, okay? It's probably good to stick with it for when we do this last one. What if in your alternate you have that, right? Do I have that typed on there wrong? Or... Oops, sorry about that. Put the not equal to on there. What's that mean? Two-tailed. Whoa, right? Two-tailed? Whoa. So this was left, right? So let's say we were going with that 10% again. Somebody said it. 0.05 and 0.05. Guys, is it 10% total? Okay, to be a really good test, which one do you normally use the most? Just of these three options. To be a really good test, you actually use the last one. Because it's at least as extreme as. You take both extremes out of that. Get them out. All right? That's a nice little cheat. Right, that's why it's your best test, because you're testing that claim. Yeah. And so what we're going to do is we're going to use some z-tests, some t-tests, some chi-squared tests. You already know how to do those. And we're going to say, well, I want it to be in here, and we're going to find out, we're going to get an answer, and let's say our answer ends up over here. You're going to throw it out, reject it. What if your answer is in here? Hey, we're good. Well, it depends on where the claim was. We're going to reject the null. Will we reject the null if it's over here? No. What if it's here? Are we going to reject the null? What if it's over there? Yeah, okay. Here, we were going to reject the null. How about there? Yeah, all right, there you go. You got it. Now, notice that I say reject the claim. I didn't. I said reject the null. If the claim happens to be there, then you reject the claim. Okay. Oh, state if it's left, right, or two-tailed. You know what? I've done the same thing on every problem. What's the first thing I've always done? I just wrote down the two hypotheses, right? Because I want to make sure that I write them correctly. I want to make sure I got everything taken care of, right? And then I look, if I'm going to look at which tail, which of the two will I look at? Your alternate, yeah. Okay. So let's see here. Aren't these the same ones? Oh, awesome. So we already did those. So what was this one again? So wait, P, is it equals? 0.82, and P does not equal 0.82. Now, which one was the claim again? First one? Now, how many tails are we going to look at? This is just a recap, okay? Two-tailed, right? Because? So, two-tailed. Do we know what percent is in each one yet? No, because I haven't told you how close I want you to get, right? I haven't said be, 99% sure or anything like that, right? I said, Just two tail. All right. And so in this case, if it falls in there, I'm going to actually reject the claim because it's actually there. All right. So how about this one? We're almost there. What was it again? Mean. Mean. Greater than or equal to, I almost put 0.25. And this is less than 2.5. Which one was the claim on this one? It was the other one, right? The alternate? Yeah, but which? Left-tailed. Yeah, because look at that thing. It's pointing left. Left-tailed. Now, let's say I go and I reject this null. Let's say we do the test. We actually reject this null. We've actually just supported the claim. Okay, you see how that's kind of all coming together now a little bit? I know it's goofy the first time you hear all this stuff. All right. All right, this is a mean again, right? Mean. Mean. We know there's an equal to on this thing. More than, so it's less than or equal to 20. And this is more than 20, and your claim is once again over here, right? So it's a right-tailed. And if I reject the null, I'm really only supporting that. Okay? So you see where you can't support this one, you can't reject that one. You see, that's how they've set them up. You're always going to try and reject this thing. Okay? And that's how you should set up your claims. Okay? So now this is probably the trickiest part. You got those? Like I said, if you get and then on the back of that last page, I just gave you a little, some of you like those flow charts, so I just kind of gave you a little something there. Read that if you want. But we've kind of talked about it, but here we go. So we're told that there's an employee group out there for a national retailer that claims the mean time spent by employees on personal phone calls is about 10 minutes a day. So they're not working, in other words. Okay? They're talking on the phone. You are asked to test this claim. Now, obviously, who asks you to test is going to change what you make the claim and everything, right? If the company asks you to do this, you're going to try and do it one way, and if the people, like maybe have a group that's supporting them, well, we're going to change things. So how would you write the null hypothesis if you represent the employee group and want to support the claim? So in other words, we want to support the claim. So where do I want to put the claim? Where do I want to put the claim? In the alternate, right? I want the claim over here if I want to support it. It's the only way to do it. And it's mean, right? So we're going to say that over there and over here. We got mean again, but we know there's an equal to somewhere on that side, right? So is about 10. So one way you could do it, again, if you're trying to help them, you're probably going to say less than, right? If you're really trying to help them. Because you could say not equal to 10, but maybe you'll find out it's actually like 15, right? So that would be bad, okay? So less than 10. And over here you're going to say greater than or equal to 10, because if I can reject that darn thing, I am supporting that. And what tail test would this particular one be? Ah, very good. So how about this one down here? So now I think I want to reject the claim. So where do I have to put the claim? Yeah, I got to put it on the other side. And so now, if I'm working for them and I want to reject that darn thing, let's face it, what are they going to do? What are they going to put here? The company's going to put what there? Less than or equal to 10. That's what the company's going to put there, right? They want to sit there and say, ha-ha, I rejected that. You are wrong. Okay? Because that's where the claim is. And over here we'll put, and so what test are you going to use? What tail? Right tail. Okay? So do you see how your point of view or what you want to actually have happen changes where you put things? Okay? Because as that company, you want to say, gotcha. Go to work. Where here you want to say, I rejected that, so we are actually less than 10. Okay? Tricky business. Who knew stats was so tricky?